this session we will study about the straight lines. Different forms of straight lines are there. You can see here that the general form, 2 points form, point slope form, slope intercept form, normal or perpendicular form, parametric or distance form. So look at this, the different sorts of forms are there of straight lines. Ax plus by is equal to c is the general form. This one is 2-point form. Y minus y1 is equal to y2 minus y1 over x2 minus x1 multiplied by x minus x1. This is the 2-point form. Now this one is the point slope form. Y minus y1 is equal to m multiplied by x minus x1. This is the slope intercept form. Y is equal to mx plus c. This is the slope intercept form. And this one is intercept form. X over a plus y over b is equal to 1. And this is the normal or perpendicular form. X cos alpha plus y sin alpha is equal to p. Now this one is parametric form. X minus x1 over cos theta is equal to y minus y1 over sin theta is equal to y. So these are the different forms of straight lines. Let us see the derivation of different forms. So first of all we'll look at the 2 points form derivation. Now look at this in this graph. This is our x-axis, this is our y-axis, or this is the line for which we have to derive the equation. There are 2 points given on line. The coordinates of 2 points, there are 2 points A and B, or we see that the coordinates of point A x1 comma y1 and point B is x2 comma y2. We take a variable point P on this line whose coordinates are x and y. So what I will do first, I will draw the perpendicular. From A to x-axis. This one is our one perpendicular. Now another perpendicular from point P on an axis, another from point B, these are our perpendicular we have drawn. Now I am drawing another perpendicular from A to, first I put the I give the name to this point on x-axis. So you look at this. This is L, this one is M, and this one is N. Now I draw another perpendicular from A to BN. On BN I am putting one perpendicular here. Is also a perpendicular. Now we have perpendiculars are here. This one is perpendicular, this one is perpendicular, this one is perpendicular, and this one is perpendicular. I give some name to this point also. R and S I am putting here the name. This one is R and this one is S. So we see here there are different triangles formed here. One is BAS is a triangle, and another I am taking a triangle PAR. We have to first prove the similarity between these two triangles. So in triangle BAS and triangle PAR. You see, in BAS and PAR, the angle A is common, angle BAS is equal to angle PAS, it is common, and angle PRA and BSA are 90 degree, both are 90 degree. So angle BSA is equal to angle PRA is equal to 90 degree. So both are similar by the property asimilarity, criterion of asimilarity. Therefore, triangle BAS is similar to triangle PAR. Now, the ratio of their corresponding sides should be equal. The corresponding sides, the ratio of corresponding sides should be equal or the proportional. So we will write here AS and AR both are proportional, and BS and PR. So I am writing here BS upon PR corresponding sides is equal to AS upon AR. Is it clear now? So we'll put the value of BS. How we will get the value of BS? So because BN is Y2 and SN is Y1, so BS is Y2 minus Y1. Okay, so we are putting here Y2 minus Y1, Y2 minus Y1, and PR, PM is Y and RM is Y1, because the AL is Y1, so RM is also Y1, so it is Y minus Y1. Now you see AS, because the ON is X2 and OL is X1, so LN is X2 minus X1, which is equal to AS, so it is X2 minus X1 and AR, because OM is Y and OL is Y1. Oh sorry, here we have to see in this perpendicular, we have to find out AS, we have taken AS and AR. Okay, OM is X and OL is X1, so LM is X minus X1, it is X minus X1. Now what we have to do, I am inverting this all, making in this way Y minus Y1 upon y2 minus y1 is equal to x minus x1 upon x2 minus x1. I am just inverting to this, and you see y minus y1, this one is remaining here, and this y2 minus y1 I am transferring to other side, so it will y2 minus y1 upon x2 minus x1, and this x minus x1 is here I am putting x minus x1. So this is the derivation of 2-point form if the 2 points are given and the coordinates of 2 points are given, x1 y1 and x2 y2. You have to find out the equation of a straight line, then you will put x1 y1 here in this formula, and you could easily get the equation of the straight line. So this is the first way we have seen to find out the equation of a straight line. Now I would like to tell you something else about the slope of the line here. How will get the slope of the line? You see here, look at this, this is the angle a line making which a line making with x-axis is theta. If you have to find out the slope, that would be bn upon whatever the point is. This is the slope is equal to tan theta. Okay, so we have to find out the slope, which is tan theta. Or how we would find out that slope? The perpendicular upon base is the slope. So here, see in this triangle BAS, in triangle BAS, angle as is equal to 90 degree, and this one is theta. So this line A is parallel to x-axis, so this would be theta. Okay, so in this triangle this is theta, so tan theta is equal to BS upon AS, BS upon AS. Now BS we know that y2 minus y1, and AS we know that x2 minus x1. Here this one is BS and this one is AS, x2 minus x1. So this would be the slope of a line, and the value of this tan theta is denoted by small m, which is the slope or the gradient of a line. So in this way we could easily find out the equation of the line or slope of the line also. So this is the slope of the line. Now look at the second form of line. Through this we will explain here. Here we know that it is the slope. If the slope is given, the slope intercept point slope form we are going to derive now. In point slope form, what we have to do first, only just y minus y1, the point is given, and the slope slope is also given, which is m is given already, so it is x minus x1. So in this way we could easily find out the slope of a line. This is the slope point form we could easily derive. Y minus y1 is equal to mx minus x1, because we have seen here m is equal to y2 minus y1 over x2 minus x1. We have put instead of these m, or if the slope is given and one point coordinates is given, so then you could easily find out the equation of the straight line. Now we see the third. Let us see the slope intercept form. The slope is given and the intercept of given on y-axis, which is c. C is given and the slope m is given. So the coordinate of this point would be 0, c. So we know that the point slope form is y minus y1, because we know that y minus y1 is equal to m x minus x1, we have seen earlier. So we have to put here y minus, instead of y1 we have to put y1 is c, and m slope is given x minus 0. Y minus c is equal to m into x. So we will transfer c to other side, we will get y is equal to mx plus c. So in this way we could easily find out the slope intercept form of a straight line. Now we see the slope, we see the intercept form, which is x over a plus y over b is equal to 1. Let us draw a line here. We draw a line. This one is our line, of which whose equation we have to find out. So this is our line, this is our x-axis, this is our y-axis, this is the origin, and this is the line whose equation is to be found. And we know that there are 2 points with intercept x and y, both the coordinates axis at and b respectively. So we see this is a point A, this is a point A, and this is a point B. And let us see that the intercept OA is equal to small a. This is small a. Therefore the coordinates of point A would be a comma 0, and the intercept on y-axis, which is OB, is equal to b, small b, represented by small b, and the coordinates of point B would be 0 comma b. Now we have 2 points here and b, and the coordinates of 2 points we have a comma 0 and 0 comma b respectively. So what we have to do, we know that the 2 point form of a straight line, already we know the formula, because y minus y1 is equal to y2 minus y1 over x2 minus x1 x minus x1. Now what we have to do, we have to just put these values here, because we know that x1 here is equal to a, y1 is equal to 0, x2 is equal to 0, and y2 is equal to b. You could see here. So we just have to put these values here. Y minus y1 is 0, y2 is b minus 0, x2 is 0 minus a, and x minus a. Now we will simplify this. Y is equal to b upon minus a, x minus a. We transfer this a to this side. Ay is equal to minus bx plus ab. Implies to bx we transfer here, so it will get positive bx plus ay is equal to ab. Now dividing by this ab both the sides, we will get bx over ab, ay over ab, and ab over ab. We get now b and b will eliminate, and a will eliminate, this whole will eliminate and get 1 here. So we get now, finally we get x upon a plus y upon b is equal to 1. So in this way we could easily find out the derivative of intercept form. It is the a is the intercept on x-axis and b is the intercept on y axis. So the equation would be x over a plus y over b is equal to 1.